This video is on prime and composite numbers, lowest common multiples, highest common factors, evaluating powers and roots, and prime factor trees. So doing 7 questions here. Feel free to skip forward to the question you're interested in. The times are in red if you want to skip to that question. Okay, question 1 is testing numbers whether they are prime or composite. So I've got 3 ones here, let's go through and test. So here's how I would do it. 117. I'm going to try to find whether 117 has other factors than 1 or 117. So let's try it. Well, I know that 2 doesn't go in 117 because every multiple of 2 is an even number. How about 3? Well, let's get near it. I know that 3 times, let's say, 40 equals 120. Okay, that's good. I'm really close. So therefore, if I went 3 times 39, 3 less than that would be 117. So there we go. 3 goes into 117. So I can say that 117 is composite. Great. Now let's have a look at 19 now. 2 doesn't go into 19. Does 3? Well, I know that 3 times, say, 7 equals 21. So 3 times 6 equals 18. So 3 doesn't go into 19. I know 4 doesn't. 5 doesn't. Let's say 6 times 3 equals 18. 7 doesn't. Does 8? 8 times 2 equals 16. Close, but it won't. 9 times 2 equals 18. Okay, so now I can safely say that no other factors go into 19. So I'm going to say 19 is prime. Now, this big number over here, it looks big and scary, but this is a very good indicator on the right. This is an even number, so I can straight away see that 2 will go into this number. So, if 2 is a factor, then straight away, composite. And there we go. Okay, question 2 deals with lowest common multiple. So lowest number that both numbers, or all 3 numbers, go into. So the first one on the left here, 2 and 8. Well, 2 goes into 8, and also 8 goes into 8, because 1 times 8 is 8, so the lowest common multiple equals 8. Easy. Now let's look at the second one. Well, 4 doesn't go into 18, so the lowest common multiple isn't 18 this time. How about we try when we times 18 by 2? That's 36. Now 4 also goes into 36, because 4 times 9 is 36, so I can say that the lowest common multiple that both number goes into is 36. Okay, let's have a go at this one on the right here. We've got 3 numbers this time, so this is going to be a little bit tricky. Okay, so I need a number which all 3 of these numbers go into. Now, I've got a 15 here, so what about I need this to be a number with a 0 on the end so that 10 goes into it. So if I times 15 by 4, I get 60. Now, 20 also goes into 60, because 20 times 3 is 60, and 10 times 6 equals 60. So, using my head, the lowest common multiple equals 60. Okay, question 3 looks at highest common factor. So the highest factor, which goes into the numbers that we're looking at. So let's start with an easy one on the right. Now, for these highest common factor, a trick that I use is to look at the smallest number and usually work from the highest factor. So I usually halve the smallest number. So let's look at 3 times 2 is 6. So let's look at 3. Does 3 go into 6? Yes. And does 3 go into 9? Well, yes. Okay, so the highest common factor equals 3. Okay, let's look at the second one now, slightly harder. Again, I go to the smallest number, 24, and let's halve 24. So 12. Now, does 12 go into 30? Well, it doesn't. No. 12 times nothing equals 30. Now, let's try 6. So 6 times 4 equals 24. So let's see if 6 goes into 30. Well, 6 times 5 equals 30, so that's great. So the highest common factor equals 6. Now, 3 numbers here, so this is a little bit harder. Let's look at the smallest number here, 32. And let's look at the highest factor of 32, which is 16. Now, does 16 go into 60? It doesn't, so we discount 16. Now, let's try, what other numbers go into 32? Let's try 8, because 8 times 4 is 32. Now does 8 go into 60? Well, it doesn't, because 8 times 8 equals 64. So we can discount 8 now. Let's try another factor of 32, 4. 4 times 8 equals 32. Now does 4 go into 60? Well, 4 times 15 equals 60, so good. Now we've got to check for 48. And 4 times 12 is 48. So highest common factor equals 4. Okay, question 4 deals with evaluating powers. Now let's talk about what this word powers means. Powers is this little number which is slightly higher and to the right of the big number. Now what powers means is how many times the big number is times by itself. So using an example, 13, which is the big number, to the power of 2, or we like to call that 13 squared, is the same as writing 13 times 13. So 13 is written 2 times. And that, using multiplication techniques we showed in the last video, or your head if you're good at multiplication, is equal to 169. Now, let's look at the second example. 7 to the power of 3, or we can also call that 7 cubed. Now, that's the same as writing it as 7 times 7 times 7. 7, 7, 7, 3 lots of 7. And that is equal to 343. If you're unsure on how we got that, have a look at the last video on how to times some large numbers. Question 5 looks at evaluating root signs. Now you're probably thinking, what the hell is a root sign? Well, a root sign is this little funny looking symbol that I have here in my 3 questions. Now, let's look at the first and second question. I just want to clear up a little misconception that some students have. This square root sign is the same as writing a little 2 here, looking at the square root. Compare that with the third one here, which is the cubed root, and the 3 is written. For some reason, don't ask me why, when it's a square root, the 2 isn't written. So just be careful for that. Now let's look at what it actually means. The square root of 16 is asking you which number squared equals 16. So using our head, we know that 4 to the power of 2, or 4 squared, equals 16. So reversing that, the square root of 16 equals 4. Let's go look at the second one here. Square root of 121. So we're trying to find what number to the power of 2 equals 121. Or what number times itself equals 121. Well, we know that 10 times 10 equals 100. So we're close. What about 11 times 11? And that, bang, good, 121. This can also be written as 11 squared equals 121. So, reversing this now, the square root of 121 equals 11. And that's our answer for that one. Now this one here, cubed root, this is the hardest of the 3. So we're looking at which number to the power of 3, or which number, let's draw just a circle representing a number, to the power of 3 is equal to 512. Bring this in, there we go. So, now this is a bit tough on the head, but let's have a look. Let's try a number. Let's try 5. 5 times 5 times 5 equals 125. So a little way off there. Now how about let's try 8. So 8 times 8 times 8. And that actually does equals 512. So we got lucky there with that guess. So 8 to the power of 3 equals 512. Or the cubed root, which is what this is called, of 512 equals 8. And that's our answer for that one there. Okay, question 6 looks at what we call prime factor trees. Now these might look a little scary, but they're okay. What we need to know with prime factor trees, we really do need to start learning our prime numbers. And I remember my dad used to teach me how to do this. He used to always say, on the right-hand side of your page, let's write the prime numbers up to around 30. So I got good at doing this. Now, so I went, okay, 2, and this became a bit by memory. 2, 3, 5. These are all prime numbers. 11, 13, 17. If you practice this, you'll get good. 19, 23. Now, let's go up to there. That'll help us for these questions. So these are all prime numbers, so the only factors are 1 and the number itself. No other number divides into these numbers. Alright, what do we do for prime factor trees? We need to let's look at the first one, 196. Let's look at 2 factors, one of which is a prime number. Now, if it's an even number, you straight away go use 2 and the other factor. So I'm going to start drawing my tree. 2 times 98 is 196. Now let's look at 98. 2 is good. You can't go any lower than 2. Now let's look at 98 against an even number. So use the 2 again. And now 2 times 49 is 98. Now this is no longer even, so we're going to have to use some other of these numbers here. Now, we're looking at a prime number which times into 49. Well, 7 times 7 is 49, and that's actually really good because your tree finishes when all your factors are prime. So 2's prime, 7 and 7. So the final answer to this question is to write these end numbers like this. 2 times 2 times 7 times 7. I'm a little close here, but you can see what I'm doing. And like in question 5, 2 times 2 can also be written as 2 to the power of 2. And 7 times 7 can be written as 7 to the power of 2. So this is our final answer here. Now before I move on to 63, actually I won't rub it out, I'll draw a little line around it. Okay, let's look at our prime factor tree for 63 now. Now it's not even this time, so we can't use 2 straight away. So now we need to start looking at this list of prime numbers. Now, I like to start at the very top to make it easier in my head. So 3 times 21 is 63, so I'm going to use 3 and 21. So 21 isn't prime, so now I have to look at 21. Now, I know that 7 times 3, both of which are prime, equals 21. So 7 and 3. And there we go. All of our last numbers are prime, and this is where the tree finishes. Now, in order to now go and write the final answer, this will be written as 3 times 3 times 7. And we know that 3 times 3 can be written as 3 to the power of 2, or 3 squared, times 7. Okay, so this is your final answer for the factor tree of 63. Okay, question 7 is, this is a difficult question, an advanced question in this topic, and it's finding the lowest common multiple and highest common factor using prime factorization. Now, we'll stress that this is a bit difficult, so you're going to need to do some practice here, and I'll show you how to do this one, which is probably a harder one, and see if you can follow what I'm doing. Alright, so the key to starting this is to draw a prime factor tree for both of the two numbers, similar to question 6. So let's go ahead and do that. If you're wondering how to do the prime factor tree, have a look back at question 6, so I'm just going to go through this quite quickly. 126, I know that that will be 2 and 63, and from 63, I know that that will be 3 and 21, and 21 I know is 7 and 3. So this is 2 times 3 times 3 times 7, and that can also be written as 2 times 3 squared times 7. So first one done. 105, let's look at 5 and 21. 21, this is already prime, 21 is 7 and 3. Great, so we're finished here, these are all prime. This is 5 times 7 times 3. Okay, step 1 done. Now, we need to find the lowest common multiple, and we also need to find the highest common factor. Okay, these are the two things we need to find. Now, for lowest common multiple, we need to find all of the different types of numbers that are found in both answers. So it's found in both answers, I'll stress that. So 2, 3, 5 and 7. So 2, 3, 5 and 7. Note though, if a number is in both and has a power, you need to raise it to the highest power that's seen. So see here that 3 is raised to the power of 2, so we're going to make it like that. And we'll go ahead and, okay, I won't do this in my head and write it out. I'll whip my phone out here and we'll go 2 times, go back here, let's go 2 times, now 3 to the power of 2 is 9, so I'll just go ahead and do that, times 5 times 7. So lowest common multiple equals 630. Okay, let's look at highest common factor now. Now, highest common factor, you need to find numbers that are common in both answers, so they can't just be in one. So 2 is only in this left answer, so that's not 1. Now 3 is, 5 isn't in the left one, 7 is. There we go. Now, unlike lowest common multiple, for highest common factor, if 3 is in both and 1 is to a high power, you go to the lowest power. So this one here is just 3 to the power of 1, so I'm going to leave it as 3 to the power of 1. Now, 3 times 7 equals 21. There we go. So lowest common multiple, 630. Highest common factor, 21.